Hi, so I'm going to go ahead and show you how to draw a Lewis electron dot diagram and how to write the formula for an ionic bond. So let's go ahead and take a look at a few things. First and foremost, you should have this periodic table that shows you the number of valence electrons per group, and this is, remember, just for those representative groups, which are groups 1, 2, those with the letter A, then 3, 4, 5, 6, 7, and 8. In addition, we also have charges, and these charges tell us whether these particular atoms are going to be giving electrons, and if that's the case, then that means that they're going to be positive because they're giving away negative electrons. And if they happen to be negative, that's because they are accepting electrons again, which are negative. All right, so for our example, we're going to go ahead and look at calcium and nitrogen. All right, so in regards to the steps that we're going to follow, here they are. So step 1 is to write the electron dot diagram for each one. So calcium happens to be in group 2 if you look that up on your periodic table. So therefore, we're going to go ahead and put its electron dot diagram just like this. And then if we look at nitrogen, that happens to be in representative group 5. So it has 5 valence electrons around it. Remember, we're going to fill the quadrant before we put it in pairs. 1, 2, 3, 4. There's a 5th one. Okay. It says step 2, make sure to place the metal or cation first and the non-metal second. All right, so calcium is on the left-hand side of the periodic table, so we know that it's a metal. Therefore, it being first is good. And then nitrogen is a non-metal, and it happens to be on the right-hand side of the periodic table. So we're in good terms so far. Step 3, identify any unpaired electrons. So let's go ahead and look at the ones that are paired already. And those are the ones where we don't want to touch. So here's nitrogen. These guys are paired. We want to leave them alone. So I'm going to go ahead and color them in red so we know to leave them alone. But we see that calcium has 2 electrons that are unpaired, and we see that nitrogen has 3 electrons that are unpaired. So let's see what it says for the following step. Step 4. Show a line that goes from one of the unpaired electrons in the cation to one of the unpaired electrons in the anion. Let me go ahead and use a different color. All right, so I'm going to want to go ahead and bring this over here. So this calcium is going to give away an electron to this nitrogen, okay? The reason it does that is because calcium, it's not very close to having its 8 valence electrons, but nitrogen is. Okay, calcium has 2 and nitrogen has 5. So nitrogen benefits from gaining these electrons, but calcium also benefits by giving them to someone that wants them, because when they bond, they become more stable. So therefore, as it transfers that electron, guess what? It's no longer there. It was transferred over to the nitrogen. So according to this, it says continue to pair those electrons and add cations or anions until evenly paired. Okay, so we went ahead and paired this one, and we're going to continue until they're evenly paired, right? So here we go. We're going to go ahead and bring it over here. All right, so therefore there is, that one's no longer there, right? But here's a problem. We got rid of all the electrons that are unpaired in calcium, but if you notice, nitrogen has that one electron that's unpaired, and we can't let that happen. So what we do in this situation is we create another calcium with 2 valence electrons like we did. And then we're going to give an electron to this nitrogen. Okay, now if you could tell, now nitrogen is full, it has 8 around it, but here's a problem. Now calcium has that extra electron, and that can't happen either. So guess what? What you did with the calcium, you're going to do with the nitrogen. So we're going to draw another nitrogen, and don't forget the nitrogen had 5. There it is. And so that unpaired electron from the calcium is going to go to the nitrogen. And there it is. Yep, as you are looking at this situation, you see that we're back to square one, which means that we have these 2 electrons that are unpaired. So guess what we're going to do? If you guessed that we are going to have to put another calcium, you're absolutely correct. So we're going to create another calcium. Again, 2 valence electrons. And we're going to go ahead and transfer them. Okay, there it is. So therefore, this doesn't have it anymore. And now notice that we're finally evenly paired, just like it said in step 5. And there's one thing that I'd like to have you do as well. Okay, so every time you give away electrons, just like calcium did, you're going to say that you have a +2 charge because you got rid of 2 negative things. Okay, so here are these calciums, +2 charge, +2 charge. But if you notice with the nitrogen, let's look at how many it gained. Okay, it took 1, 2, 3. So it gained 3 electrons. Okay, same thing with this nitrogen. It gained 3 electrons. But now, why is it negative if it's gaining? Because remember, electrons are negative. So you're gaining 3 negative things. And here, on the other hand, you were losing 2 negative things. Okay, so now the other thing I want you to notice is we're going to go ahead and write the formula in 2 manners, okay? So first of all, I'm going to ask you, how many times did you have to write calcium, the electron dot diagram for calcium? Let's see, it's 1, 2, 3 times. You had to write it 3 times. So when you're writing the formula, you're going to say, here I am using calcium with a subscript 3 times, okay? How many times did you have to use the electron dot diagram for nitrogen? So we're going to go ahead and write this down. Nitrogen, we used it twice. Okay, bingo. That is a formula for calcium and nitrogen, which we call calcium nitride. Okay, we call it calcium nitride because it's like when someone gets married, their last name changes. So nitrogen, we take away that ending and we make it an IDE. Okay, so it becomes calcium nitride. Okay, but here's the thing. This is how to see the whole picture. This is showing you what's going on, right? But we do have a bit of a shortcut. And that shortcut is called the crisscross method to finding the formula. Okay, so I'm going to write down so you know. This is a chemical formula. But the shortcut is to go ahead and take your calcium, which if we looked at our periodic table, we knew that it was labeled as a +2 charge, but now we know why, right? We know the reason why it was a +2. And we look at that special periodic table again, and we see that nitrogen is a -3. And what you do is you take the number value. Okay, when you do that, we can get rid of that positive. We take the number value. When we do that, we get rid of that negative, and we cross it down into subscript numbers. Cross that one down into a subscript number. then once you cross it down, you know, it's no longer there. So our formula is Ca3N. Okay, so this is called, or this is what I call the crisscross method for finding chemical formulas. Okay, again, granted that when you draw a Lewis dot diagram like we did here, okay, the advantage to that is that you get to see step by step what's going on in the Y. Here, once you're already comfortable with what's going on and you understand, then you can go ahead and do the crisscross method. And this is how you get that information.